Alright guys, this video is for 8.1, multiplying and dividing rational expressions. So let's see here. A ratio, simplifying rational expressions. It's a ratio of two polynomials expressed, two polynomial expressions such as 1700 over d minus 33. That's the example they put in the book, so it's the example I put up here. It's called a rational expression. Basically, it's a fraction with more than just numbers in it. Second bullet's pretty important here as far as where we're going long term with this chapter. Because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are very, very similar. Just as with reducing fractions to simplify a rational expression, you divide the numerator and denominator by their greatest common factor. Essentially what it means is, like, let's say we have 8/12, alright, and we reduce it. They break it up here to 2 times 4 and 3 times 4 because the greatest common factor between 8 and 12 is 4. And so, you don't necessarily show this work, but that's essentially what you are doing. So when you reduce fractions, you divide it by the GCF, which is 4. Essentially these cancel, and you're left with the 2/3. That's essentially what we're doing with our rational expressions. We're going to take these polynomials, express them as their factors. For example, x squared minus 4x plus 3 factors x minus 3x minus 1. X squared minus 6x plus 5 factors x minus 5x minus 1. So these two polynomials have a GCF of x minus 1. Those cancel. You're left with x minus 3 over x minus 5. So that's basically what we're going to do in this section. We're going to start with single variable polynomials, then we're going to move our way into multivariable polynomials, and then move into monomials times monomials and other things. So this lesson is going to be a little lengthy. Apologize in advance for that, but we got a lot to cover in this lesson here. So the first one, simplify. Under what conditions is the expression undefined? So we have 5x times the quantity x squared plus 4x plus 3 all over x minus 6 times x squared minus 9. So your first step to simplify is to factor everything. So we're going to factor the numerator, 5x we're left with, and then x squared minus 4 or plus 4x plus 3 factors x plus 3 and x plus 1 from chapter 4 with how to factor that guy all over. You're left with the x minus 6, and then x squared minus 5 or minus 9, sorry, factors x plus 3, x minus 3. So your first step is to go through and factor everything. After you factor everything, since these are fractions, you can cancel the like terms in the top and the bottom. So these x plus 3's that are common in top and bottom, you can cross them out. And from there, you rewrite your answer as the product of all the factors. X minus 6, x minus 3. I.e. to say, you don't need to FOIL these all back together, okay? Your answer you can leave as a product of the factors themselves. So you don't need to go back through and distribute this through. You don't need to go FOIL this. This is your final answer for the simplifying part of the question. Alright, now whenever, and this is the weird one because since it is in one variable, what the book likes you to do for being ready for what we're going to do later on this chapter is we need to figure out where the denominator, under what conditions is the expression undefined. So we need to figure out what would make the denominator become 0. And just like how we did in chapter 6 with functions and division, we set these equal to 0 and solve. So you're going to do the same thing here, except you do it with the original. And that's where a lot of people mess this up. You don't do it with your answer. You go back and do it with your original. So take your original denominator. So we have x minus 6, and set each factor equal to 0, and then solve each. So the first one, we add 6, so x equals 6, great. Second one, add 9, square root it, plus or minus 3. So x cannot equal these three numbers, 6, 3, or -3. Okay, so you have to do both, and that's the weird part. You have to do it with the original as far as finding out where the denominator is undefined or the function, the expression is undefined. Like I said, it'll be for single variable expressions, so there's only x's in this one, so that's when you'll know to do this. It'll also say in the directions too. Once we get into multivariable ones, you don't get asked that anymore. Okay, so we have this one here. Same way, same process. Go ahead and answer the question that's about to pop up here. Okay, so there's the answer to the second one here. You have 2z times z plus 4 all over z minus 1 with undefined ones at 1, 2, and -5. So that's the first style of questions where you have just single variables and then you figure out where you define. Now, most of the cases, sometimes we're going to move into multivariable ones like this. So your second one here, we have 4w squared minus 3wy times the quantity w plus y over 3y minus 4w times 5w plus y. Tricky example here. First up top, we're going to factor out the GCF of whatever terms we see. So we're going to take a w out of the first group. So we're left with 4w minus 3y times w plus y all over. Now, if you look closely, and this is where this gets a little ugly. If you look closely here, we have a 4w minus 3y term here and a 3y minus 4w term here, which are the exact same except their signs are off. So to fix this, the bottom term here, we're going to go ahead and take a -1 out of there, which will then switch your signs to 4w minus 3y and then 5w plus y, nothing to cancel there, which will give you something to cancel. Okay, so every single one of these, there should be something to cancel out. You shouldn't go through these problems and not cancel anything. So sometimes that'll take factoring out a -1 out of one of your groups. Okay, so keep on the lookout for that of opposite signs, of same terms but opposite signs, because to fix that you'll have to take that -1 out, cancel them out afterwards. I'm going to move the negative to the top, so make this top be a -w times w plus y, all of the term left in the denominator, 5w plus y. And that's your answer. Like I said earlier, once you get into your multivariable terms, multivariable expressions, you don't have to worry about the denominator being undefined because it's multiple variables. We don't do that anymore. So that's one. It's the same process. Just be careful on that negative. That's a little bit of a trick. It shows up in this one too. So go ahead and answer this question also here. You got ab squared minus 5ab over the quantities 5 plus b and 5 minus b. Okay, so hopefully we factored out AB that you see in the top. AB will give you b minus 5. Keep the 5 plus b the same and factor the negative out of the second one here. See how you have opposite signs, b minus 5 and 5 minus b. So that's where the negative sign comes out. If you didn't move it to the top from this one as far as putting it in your answer, you'll be fine. I'll give it to you. But get in the habit on a quiz or test, putting that numerator, that negative in the numerator. Once again, it's proper where it needs to be. Nobody likes negatives in your denominator, and plus then you'd have to have this in parentheses. So get in the habit of putting your negatives in your numerators. So the book for this lesson, and I pretty much always follow the book as far as they do things, even though sometimes I don't agree. They kind of jump around with this. To me, this should be towards the beginning of the lesson, before we do all the factoring with polynomials and whatnot, but here it is anyway. So now we're going to move into questions where you have to multiply these monomials together, and this can become kind of nasty it's not hard, but it's easy to lose track of what you're doing. You have 6c over 5d times 15cd squared over 8a. There's a lot of different ways, a lot of different logics to doing this. Your first logic way to doing it is to put them together like you would in chapter 5, where you multiply your tops together and you multiply your bottoms together. So you'd have 90c squared d squared all over 40 AD. That's one way to do it. And then reduce that monomial from there. So you can take a 10 out of the 90 and the 40 to give you 9/4. The c squared stays, and then this d cancels out one of these d's, so you're left with a d there, and you're left with an a down below. That's one way to do it. There's nothing wrong with doing it that way. The other way you could do it, and since this is being, a monomial together, we know eventually we're going to put these together like this. And this is the way my teacher taught me to do this, and like I said, it can kind of become a chaotic mess. You start canceling things top and bottom, and this makes sense with bigger numbers. For example, 5 goes into 15 3 times. Okay, and then you see that the 6 eighths, you can reduce them by 2 to give you 3/4. And then this d cancels one of these d's. And then you multiply them together, which will give you 3 times 3 to give you the 9. The c times c gives you c squared, and the d that's left over the 4a left in the bottom. So I'm not saying one way is right and one way is wrong. Obviously, this way is a shortcut way if you can keep track of your mess, which is typically my problem. Sometimes I'll lose track of my mess. So then you can put it like this, which, is fine. But sometimes, like look over here, you're eventually going to get bigger numbers. And sometimes the numbers especially, it's harder to see, GCF out of them. Obviously you can use your calculator for this, but either way. So I don't really care how you do it, just that you show me one line of work at least. Or, either this line of work here or the simplifications up here. The only thing to pay attention to here is if you're dividing by a fraction, obviously you need to multiply by the reciprocal. So we need to flip this guy and multiply. So 18xy cubed over 7a squared b squared times 35 a squared b over 12 x squared y. And so like I said, now you're getting into bigger numbers, 18 times 35. So sometimes, it's easier just to do this without that. So like, especially one when it works out real nice. Because if you see that 7 cuts in that 35 5 times, that cuts your problem down right there. Okay, so sometimes it's easier just to cut them beforehand. 18 twelfths becomes 3 halves, like this. And just see it from there. I'm not saying one way is right or one way is wrong. It's personal preference, to be quite honest. So I'll put these together like that. The a squares will cancel out from there. This x cancels an x. So maybe the best way to do it would be to do your numbers as you go. So you have 15 over 2. Let's see what we finished up. B's. No a's cancel, so the b's, let's see, 1b up top and the b there, so there should be 1b down below. And there should be an x down below, we did that already. And then this y cancels one of these y's to give you y squared up top. So that should be your final answer. If you want, like I said, you can do these to where you have them put together as one big lump sum. It'd be 630 over 84, and then reduce that in your calculator. So that'd be another way to do this. It's really, like I said, personal preference on however you want to manage it. You should get to the same answer either way. That's whenever they have monomials, and you're going to have the same style of question here with polynomials too. So the process is the exact same way. You're still going to factor everything first, and that's the question that's going to come up here. I'm going to ask you to factor one of these, so it's not a huge deal. So I'm going to ask you to factor one before I start this problem. So go ahead and factor the one I'm asking. Okay, so if you first step is to factor everything. So you the top factor is x minus 8, x plus 2. The bottom factor is x minus 8, x minus 8. And since you're multiplying these fractions together, to be quite honest, you're just going to put the numerators together and the denominators together. So I'm going to go ahead and extend this fraction and add the x minus 8 over here. And then the third trinomial down below factors x plus 2 and an x plus 3. And then once you have that all done, you go through and you cancel out your common terms from top to bottom. So you have an x minus 8 here and here, x minus 8's there and there, x plus 2's there and there, which leaves you with a 1 in the numerator and an x plus 3 in the denominator. And that's it. Okay, so same process, just factoring all your trinomials, canceling out your like binomials after that. Okay, so in the next one you have a question on this one here. Want the full-blown answer, make sure you set it up, parentheses in your answer, make sure those look good. Like I said, I'll look at it pretty close to make sure it's close to right as far as you formatting it in. But you have x squared minus 16 over 12y plus 36 divided by x squared minus 12x plus 32 over y squared minus 3y minus 18. Alright, so I'm going to pick this problem up here. This is after I factored everything. So x squared minus 16 factors x minus 4, x minus 4. Where it might have gotten you on this problem, 12y plus 36 has a GCF of 12. So don't forget about that. And then the second place, maybe multiplying, it's still a division, so you still have to flip this. Okay, so it still has to be the factored form of y squared minus 3y minus 18 on top, x squared minus 12x plus 32 factored on the bottom. Sometimes the problems are nice because it kind of tells you that, because the first one here has x's, and so if we're going to eventually cancel something, these x's have to end up on the bottom. And that's why that works out. So sometimes the problem can give you little hints like that to remind you, hey, you got to flip this side. So you flip it and then you factor it out. You have x minus 6, or y minus 6, sorry. Y minus 6 times y plus 3. And you have x minus 8 times x minus 4. Remember, you're multiplying these fractions, so essentially you can just turn them from two fractions multiplied into one big fraction. And then go through and cancel your like terms. So you have x minus 4's. That canceled there and there. And you have y plus 3's that cancel here and here. And then whatever's left, you just put them as binomials. So x minus 4 times y minus 6 all over 12 times an x minus 8. And that's your final answer for this. So that leaves us with one more topic to talk about in this video, and that topic is what's definitely seen these on the ACT before. They're called complex fractions. Complex fractions, there's a rational expression with a numerator and or denominator that is also a rational expression. Basically, they're a fraction within a fraction. So this can become a little messy to make sure you understand which fraction is like your big one. And what I mean by that is, the main fraction. So always look, if you look real close, these division bars here are longer and darker. Okay, they're longer and darker, and that's how you can tell which fraction is the middle of the two group. For example, if you look at this fraction here, x minus 3 over 8 over x minus 2 over x plus 4, the x minus 3 over 8 is considered the numerator of your fraction. The x minus 2 over x plus 4 is considered the denominator of your main fraction because of this division bar right here, splitting it into two. This is your numerator, this is your denominator. So you have to make sure you identify that split, because it's very, very important between this section and next of what you're going to do process-wise. So to start this, we're going to simplify these guys. So we have one here, a plus b over 4 over a squared plus b squared over 4. And the way you set these up, you're going to turn this into a problem like we did last time. So you have your big numerator here, a plus b over 4. And when you have it set up as a fraction like this, essentially what you're doing is numerator divided by denominator. So you have a plus b over 4 divided by a squared plus b squared over 4. So we're going to go ahead and set that up. Divided by a squared plus b squared all over 4. So after you set that up, we're going to flip that fraction on the back end, a plus b over 4 times 4 over a squared plus b squared. Multiply them fractions together like that. Where's my dot there? So put them together. You have 4's like that cancel out, leaving you with a plus b over a squared plus b squared. And a plus b over a squared plus b squared is your final answer. You cannot simplify binomials just by going, cross, 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 cross. Once you have binomials like this, you have to factor out GCFs before you can reduce them on top and bottom, or they have to be GCFs in everything. So so this one has 2 A's, this one has 2 B's. They don't all have the same. All right, so they have to be the same in all 4. So for example, if it was like 2a plus 4b plus 6a squared plus 8a squared, then you could cancel out a 2 into everything, but that's not the case. So a plus b over a squared plus b squared is your final answer. All right, now you can move these into a problem like this. I'm going to work this one out fairly quickly for you guys, just to kind of refresh on things. Okay, so we have x squared over x squared minus y squared, and from there, like I said, I guess I didn't really say it, but if you want to, you can kind of flip it in your head. So take the bottom here fraction and flip it. That way you don't have to write the division step. So times a y minus x over a 4x. Okay, so be careful here. Look at everything that factors. So you have x squared over a difference of squares with an x minus y times an x plus y over, you have a 4x from the second one, and then notice how this has a y minus x and this numerator has an x minus y. So you need to factor out that negative 1 out of the top. That way you can go ahead and cancel out those x minus y's. Okay, you have to see that, and that takes practice. All right, it takes practice to be able to see those. And you can also cancel out one of this x's with one of these x's. Okay, x on top and bottom, to leave you with negative x over 4 times x plus y. Okay, which is going to leave you with one more question with one more example in it. So that's your complex fraction that I'm asking you to simplify. Make sure you read the question before you answer it. I don't want you to actually type in the answer. It's a question about the answer. So make sure you read the question there. Okay, so picking up the problem here in your factored and flipped form. So the x minus 2 quantity squared stays up top here. X squared minus 5x plus 4 factors x minus 4x minus 1. Your 4x minus 10, which is going to end up on top, has a GCF of 2, leaving you with 2x minus 5. And x squared minus 4 factors difference of squares, x minus 2, x plus 2. So now you look at everything top and bottom, you cancel out what you can. So you have an x minus 2 on the bottom, that cancels out the second one here. You also have 2's that cancel out there and there. And that's all you can cancel out. So sometimes you can cancel out a lot, sometimes you can't. So it's just variations to the problem. So 2x minus 5 times x minus 2 all over x plus 2, x minus 4, and x minus 1, giving you 5 binomials in your denominator. Or in your answer, rather, not just denominator. So, so that's the end of this lesson, guys. Hope it went well. Your assignment for this one is going to be page 533, numbers 1 through 12.